Hello and welcome to this course on fundamentals of data science. And today we are going to look in various factors including data pre-processing steps, some points on data analysis, association analysis, graph and visual analytics. During this course or during this class, you are going to understand some background about data analysis and what are some of the basic data preparation methods. And there are a few more machine learning techniques we are going to see some introduction to, which are regression, classification, and clustering. Let's start with the first part. Here it is, the steps involved in data science processing. Initially, what we have to do is that we have to collect the data. Of course, you have a goal in your mind and then you collect your data from the sensors or different sources. The data collection itself is a huge process. It's not that easy. At times, it's not just one data. You're going to collect various different types of data from different sources, and these data might be of different format. So at times we also integrate these data or accreditation process is performed. Then comes the next step. After data collection, you go for data preparation. Well, again, this process is not that easy. It includes data cleaning process, data pre-processing steps, wherein we do a lot of manipulation with the data. At times we have to filter out some information, at times we have to transform certain data. Only after this you move on to the data analysis part. But from this first two step itself, like almost in most cases, many data scientists agree that the first few steps of this data science process itself will take more than 75% of your effort. And only after that you are going to talk about the data analysis, wherein you are going to see various methods for data analysis. And though we have for data accreditation or data preparation and data analysis, these days we have lots of tools, but still we have hard time in actual data preparation process. So once you analyze the data, you can also visualize the data, and once you get the visualization and see the results, based on that you can get out the needed insight, the takeout from the given data. So these are the very basic steps involved, and finally you are going to create a value out of the data that you have in hand. Well, eventually that is your primary goal. With the raw data given to you, you have to create a value out of this data, for which you are taking several steps starting from data collection onwards. Well, make it worth it so that you can really create a value. If you make certain mistakes or if you are in a wrong direction, including from the data collection, if you are not collecting the right data, everything goes wrong. All your efforts are in vain. So we should be very careful in each and every process so that the final things that we come out with is of value, or in other words, your effort is worth it. So some basic steps in data science processing, as we have just seen. Initially you have to define the goal. In most cases that's the important part. It's just like coming up with the right question, and then you have to go for collecting the right data that would possibly answer your question or reach your goal. Data preparation, like exploring and cleaning data, data analysis, various methods we can employ for that, visualizing data, getting insight or predictive insight we can think about, and deployment of the various methods or machine learning iterate can be done during this step. Let's quickly look into those steps in detail, which is almost the same thing that we saw here in this block diagram. So now let's move on one by one at a time. So as far as data science is concerned, the first and the primary goal is to define what is your aim, what is your main objective, what you are expecting. So we call that as defining the problem or problems that you really want to solve. This is the hardest part. Many people don't know what exactly they need. That's where we mess up things. So first and foremost thing is to come up with the right question. Unless you have the right question, you don't know what answers you're looking at. Yes, the problem should be clearly defined. Once you have the problem in hand, then you can think about various directions to find a solution to this problem. Yes, problem definition is the key part in any data science project, any data science endeavors. So you as students right now, you can think about it. It's not just following what others have done, but if you want to be innovative, if you really want to bring in the science part of data science, the problem should be defined perfectly. Does this problem really solve any real-time problems that we have? You can think about many applications of data science. Some are very interesting and really solves one of our need. Likewise, all the data science problems are of quite important. And once you have the right problem in hand, then you can move towards the direction. Okay, then as we see, once you have this problem defined well, then you can move ahead and look for the data, the relevant data that might be useful to solve the problem. So there comes the data collection. So what are we looking at? Say for example, you want to define a problem. Your problem is that like you want to make sure your community or your town where you're living in, you are concerned about the people's health, and you want to make sure that people are safe because maybe because of neighboring industrial town, it has a lot of pollution, the air pollutant. So you want to make sure that all the citizens, they well know when to come out, or if they are coming out, if it is polluted, you can recommend them wearing a mask, or just avoid coming out for cleaning the car or for going for a jogging or exercise, the outdoor exercises. In that case, you have clearly defined your problem. Your problem is that you want to solve one of the problems of the community. In this case, you want concern about their health. So you want to make sure people are aware of the pollution around them. In which case, you have to collect data, and you know that what are the data that are needed, right? Like for example, you might be wondering what is the CO2 level or other air pollutants or particulate matters, the so-called microdust. What is the level of that? Which means that you should deploy those sensors around your town to collect those information. And moreover, in a timely manner, you are going to update this information, send to the server. And based on a threshold, based on the normal levels of the pollution, if it exceeds a certain level, you are going to give an alert to your citizens, or you are going to inform them like what is the current scenario based on all the data that you have. You can give them some suggestions. Well, today is a clear day, and today you have moderate amount of pollutions out there. Or today you can mention, well, the fine dust is quite good in a sense that you can go out for walk or exercise. So basically what we are telling is that once you define the problem, then you have to collect the data that are relevant to that solving that problem. So in this case, the relevant data are the pollution, air pollution data, and if you want to include, even include the water pollution, and at times we will also include the so-called the noise pollution. Well, that's the key. And sometimes some other data can also add up to give us more informations. For example, at times social media data may also be integrated to this data to support certain facts. Maybe there is a forest fire nearby. You are not aware of it, but because of this forest fire, your town has polluted. In that case, if you could get this information earlier, you could at least alert the people who are living there about how to act. Well, let's move on with this information. We have already collected the data that are needed for solving a problem, and now you have to make sure that the data are reliable, and you can try to validate the data and proceed with certain simple techniques. So what are the ways in which you can collect the data? Yes, we talked about having sensors, for example, the pollution. For collecting data related to pollution, we need to collect data from the sensors, which can sense the PM levels or the particulate matter or other pollutants that are in the air. Likewise, we have various sources from which you can collect the data. Some are from social media, some are from internet, telecommunications, some are just available in the open database. Based on that, you can actually have predictive analytics. And at times you collect data by means of taking survey, literally going out and taking survey, or these days even digital surveys are taken. Just give them the forms, and they fill in forms digitally and they submit to you. And you do experiments. At times we do experiments to collect the data. At times we have observations or taking samples from the population and then measuring certain data. So these are various ways in which you can collect the data. As I mentioned before, as far as the pollution is concerned, you might be needing not just one or two data, not just the data from the sensors might be useful. You can still go ahead and use other forms of data that can be integrated with the current data so that you can get more accurate informations, and eventually you can solve the bigger problem at hand. Data preparations. Well, now you have collected the data. After collecting the data, the second process, and again the most important process of all, is like data preparation. So in data preparations, there are a lot of steps involved, as you can see here. Cleaning of data is very vital step. So that includes, at times you have to filter the unwanted data. There are various methods to do that as well, filtering out the unwanted data, and then you do have to transform the data based on various hypotheses. Well, you have certain hypotheses, certain assumptions. You know what is your goal. So there you have clearly identified what is your hypothesis, and based on that you have to transform the given data. At times data are of different dimensions. You may have to reduce the dimensions. you may have to manipulate certain ways to transform the data that is in hand. Data wrangling and data merging. These are another two important processes. By means of wrangling, you are getting the data in shape. For example, there may be different features in your data, and again, at times you may not use all the features to solve your problem. So you may have to be careful in using certain features, because if you use all the features, maybe it is computationally complex. We can use basic statistical information, visualization and correlations, and other ways to explore more about the data preparation process. Then comes the data analysis. This process is quite straightforward. As you can see, just the input data, the collected data has been given as the input, and we use techniques for analysis. We will see some of the models later on. You can in fact also mathematically model a certain architecture that is good for your applications, and then accordingly you can get the output or desired output. Here is the techniques. We talked about there are some techniques here. Here is the techniques for analysis. Well, some of them are machine learning methods. As you can see here, regression, classification, clustering. These three are basic machine learning algorithms, along with association analysis and graph analytics are still more effective ways of analyzing your data. Let's briefly see what are these techniques, and in another lecture we will discuss more about regression, classification and clustering. Let's see what is a regression here. Well, as we can see, it can give us linear analysis. In other words, when we talk about linear regression, it gives us the relationship between two variables, the dependent variable and independent variable. As you can see here at this part, the entire data, the points we see here are the data points, and they are linearly increasing. They have a positive correlation, you can say that. And again, here they are linearly decreasing. So these are basic linear regression methods. Well, we will be discussing about what is what with regards to regression in details in other lecture, but for the time being we can just get some information what is this regression. And we can see that this curve here is a non-linear relationship. We do have polynomial regression where we can actually have different curves to fit the data. Yeah, it is in fact, it's like curve fitting. In these two cases, we are trying to find a linear line that fits almost all the data points. That is the objective there. And once you fit all these data points accordingly, then if the new data points comes in, you can try to predict what is or what might be its value. Or you can also try to predict what happens in the future. In either line like XY axis, you can try to see what is going to be in the future. So that's one of the advantage of regression. It's a simple machine learning predictive methods and can also be used for classification. We have different types of regression. We do have a regression method called logistic regression. We will consider it later on. Okay, some information here about the classification. Again, we are going to just talk about linear classification. Yes, as you can see here, a linear classifier achieves the linear classification just a simple linear line can separate two different classes. Here in this case, you have class 1 and class 2. Say for example, apples and oranges. Yes, it's a simple linear classifiers. Or it can be cat and dog, men and women, a simple linear classifier. So when we have data, sometimes we do have to use such classifier to separate data points. Clustering methods. Yes, as we can see, the word clustering means like grouping a set of objects. They are similar. So the similar groups are clustered together in some sense, so that you can see different clusters are formed. And clustering, as you can see here, the orange group, the red group, and the blue groups are clustered together. For example, like you can say men, women, children are clustered, 3 different clusters. Or you can also have clusters like children, teenagers, middle-age group, and old group. They are different clusters. They form different clusters. So some of the similarity index can be used to have such clustering methods. Let's move further to this association analysis. As the retailers, they use this association analysis to attract the customers to sell their product. So as you can see here, a customer who buys bread, or in other words, the transaction that includes milk, whenever a customer buys a milk, 71% he also buys the bread, and 43% he includes eggs, and 29% he includes toilet paper. So that is the association with all these 4 different objects. In other words, they are kind of related to one another. So what the companies used to do is that the retailers, sometimes they place bread and milk quite closely, so that it's easy for the person to pick up the bread or milk and then take the other product right away. The same is true with egg as well. And it's interesting that even there is some association found between diapers and beers. Especially on the weekend, people whoever buys the diaper, they also buys a beer, or vice versa. So likewise, retailers are trying to find certain association with the customers. Yeah, they can analyze our trend. It's a simple analytics. Graph analytics. So we know that graph can represent various different types of networks. For example, it can even connect one people with other people by means of a social setting. So you can represent all these connections by means of a graph, either 2 sensors connected to one another, or 2 vehicles connected to one another, 2 cars, 2 buses connected to one another, or 2 individuals connected to one another by means of a mobile device, or 2 individuals connected to one another by means of a social network, for example by means of Twitters and so on. Yes, various connections can be analyzed using certain graph analytics, and once you have such things, you can actually again use machine learning methods or various clustering coefficients to analyze this graph. As you can see this diagram here, they represent various links, and this pattern, you can see that different colors represent a similar group of people, and from that you can analyze how they are spread out and how they are related and how far from each other they are placed. So if you want to go in this direction of graph analytics, yes, you can go ahead and do certain tasks. Start from the basic graph theory that can help you a lot. There are a lot of graph theory algorithms are available. For example, if you want to visit different cities, what is the best way to go from one city to another city? We have graph algorithms, right? Shortest path or minimum spanning tree. These are some of the basic algorithms that can be directly applied for graph analytics. Finally, we have the verification of data analysis. This is another important step. We also make sure that whatever process we do by means of data analysis techniques, finally we have to verify it and validate it. There are different ways in which you can validate the data that are collected, and after experiments also we have to evaluate the informations. Then only you can come up with the right output to say that you really got some insight out of it. And as far as visualization is concerned, these are three different tools that are available, like Tabular, Power BI, Excel. Excel is still a very powerful tool. If you are using Excel, you can continue to use it. But yeah, these two tools like Tabular and Power BI is getting very popular these days. I recommend you can learn any one of these tools, and they are very easy in a sense that you can learn within days. Few days you can learn about these tools. And our final objective in all the data preparation process is to get insight from the data. What is the insight? Insight is something, a knowledge that you extract from the data, but not only just a mere superficial knowledge, but getting deep into the knowledge, in fact, as if extracting the wisdom out of the knowledge. It's not about just knowing the things, like, for example, you know that when you cross the street, you have to look right hand side, left hand side, and cross. But you should also use this wisdom to make sure that if there is a vehicle coming in while you're middle of the road, you should make sure that to take the right action. That's where the insight comes in. It's not about following the rules. It's also about taking the right decision at the right time for your benefit, so that you can create a value while crossing the road. If you make the right decisions at the right time, what is the thing that you are benefited? Your life is saved. Yeah, that is the value you take out. Yes, value is very important. In some aspect of data science, we consider the money that we save might be the value. In some cases, the health is a value. In some cases, the environment, like we talk about pollution, we talk about green belt. Well, we are trying to form a green environment, a green city. Yes, that is a value that you create. We can think about what are the different values you can create out of the data that you have in hand. That's what we have seen, a basis for data analysis with various steps in data preparation process. And we saw certain introduction to regression, classification, and clustering. And also we consider how other methods like association rules can also be very useful for data analytics. And always remember that the main objective is to come up with the right insight, to take the value out. But all the more so, you have to make sure that you get the right question in track. Once you are coming up with the right question, the right problems, then you can move in a right direction to find a solution to this problem. Well, that's all we have for today's lecture, and we are looking forward to look into the data preprocessing in detail in the next lecture. that includes some more parts related to what we have seen today, that has data integration, data transformation, data reduction, and some parts of data cleaning as well. I am looking forward to see you in that lecture. Until then, goodbye.